Hello, today we're going to be looking at lesson 2-4, solving equations containing integers. The main thing is we need to remember that the goal of solving an equation has not changed. We are still trying to isolate our variable, and we are also trying to do so using inverse operations. So anytime we solve an equation, we're going to look at what is currently happening to the variable, ask ourselves what the inverse operation is, and then complete that operation until the variable is isolated. And then it is always a good idea to check your work afterwards. So let's begin in example 1 with letter A. We're asked to solve y plus 7 equals 11. So right away we see the variable is being increased by 7. So the inverse operation will be to subtract 7. So we'll subtract 7. Whatever we do to one side of the equation, we must also do to the other. That's what keeps it balanced. This will then isolate our variable, and when we subtract 11 minus 7, we get an answer of 4. So our final answer is y equals 4. To complete the check step, you just simply insert that value back into the equation. So we would instead put in 4 plus 7, and we put a little question mark here to indicate that we're trying to figure out if it does in fact equal 11. When we add up 4 plus 7, of course, we do get 11. Next, in letter B, we have negative 4 plus t equals negative 22. So again, we ask ourselves, what's the inverse operation? Now, please understand something. This 4 is negative, but it is being added to t. So the inverse operation is still subtraction, but now we are subtracting negative 4 from both sides. Now, remember, when you're subtracting a negative, what you're actually doing is adding a positive. You're finding the change, the difference in those two amounts, which ends up being an increase. You're really finding out what negative 4 plus positive 4 would equal, and it's of course 0. That's our goal. We're trying to cancel it over here, which isolates t. On the right-hand side, we're trying to figure out what negative 22 minus negative 4 was. So we would change subtraction to addition, switch the sign of the second integer, and it becomes negative 22 plus positive 4. If we're starting at negative 2 and we're gaining 4, we're still going to be in the negatives, but we are going to get closer to 0. We will now be at negative 18. So really we found the difference of those two numbers, but kept the sign of the larger integer, which was negative, giving us a final answer of t equals negative 18. Our check step then, we would just simply put negative 4 plus negative 18, and we want to know if that equals negative 22. And it does. Next, in letter C, we have 18 equals negative 9g. Now you notice in this one we have the variable on the right-hand side. That does not matter. It does not change our solving process. We still ask ourselves what is currently happening to our variable g. It is being multiplied by negative 9, so our inverse operation is to divide by negative 9. And so we will divide by negative 9 on both sides. When we divide negative 9 by itself, over here it's going to cancel and give us g, and on the left, 18 divided by negative 9, that's a positive divided by a negative, so we will get a negative answer, and it is g equals negative 2. For our check step then, we rewrite the equation exactly as it was written, but this time, in place of g, we will put negative 2, and of course we can confirm that negative 9 times negative 2 does equal positive 18. Okay, in example 2, now we have some two-step equations, but again, the process has not changed at all. We are still trying to isolate the variable using inverse operations. So we'll start with letter A, negative 2k plus 8 equals 20. Now, when doing this, we always want to do what's not attached to the variable term first. The variable term is negative 2k. It is being increased by 8. So the inverse operation would be to subtract by 8. Whatever we do to one side, we must also do to the other. So we will subtract by 8 on both sides. The 8's on the left will cancel. So we will have negative 2k is equal to positive 12, since 20 minus 8 is just 12. And then our final step here is to isolate k, and k is being multiplied by -2. Our inverse of multiplication is division, so we will divide both sides by -2. That will isolate k and give us an answer of -6. Now in the two-step equations, the check is even more helpful because there's more places for you to have potentially made an error. So let's go ahead and try a check step here. We'll go back to our original equation. This time we'll insert -6 in for k. We want to know if this equals 20. So -2 times -6 is 12. And then we just simply have 12 plus 8, which we know is in fact 20. So that does check out. Okay, letter B, we have -7 equals 2 plus y over -4. And again, a fraction is a division problem, so don't be afraid of that. Also remember that it doesn't matter if the variable's on the right-hand side. Because -4 is attached to the variable, we're going to ignore that for now, and we're going to first undo the 2. So notice that there's no sign out in front of the 2, so we know it's being added. So the inverse operation is to subtract 2 from both sides. It's going to cancel on the right. On the left, if we're at -7 and we take away 2, we're going further into the negatives. We could also think of it as changing subtraction to addition and switching the sign of the second integer, which would make this -7 plus -2, which is -9. So we have -9 equals y divided by -4. We still have to isolate y. This time our last step is going to be multiplication, the inverse of division. So we're going to need to multiply both sides by -4 so that this -4 will cancel. So now on the right-hand side, we are left with y. On the left-hand side, we have a negative times a negative, which will be positive. And in this case, it is 36. We'll do one more check step. So we have -7 equals 2 plus 36 divided by -4. We want to know if those are equal. So first thing, we would divide the 36 by -4, and we'd get -9 because it's a positive divided by a negative. And then we can, of course, see that 2 plus -9 would, in fact, be -7. So that also checks out. Okay, thank you.